Have a look. So the sixth program is having two parts, 6A and 6. Sixth A is only the Lex program, and 6B is combination of Lex program. The sixth A program is to write a Lex program to eliminate the comment lines in a C program, and after eliminating, the rest part of your program should be copied onto your another file. So you should read an input file containing C program as well as comments, and you should write it into an output file, which is what we call it as C program without comments, right? And we do have two types of comments in C program. We know a single line comment begins with a double slash and ends with slash, and the multi-line comments which start with the slash and star and ends with star and slash. Means in the multi-line comment, the new lines are also included. You can have a space, you can have a new line, all these things. But in a single line comment, your comment line starts at the beginning of the line where you find the double slash and ends with a slash. That's what it's a thing. And this program is only Lex program. It's not a Lex and a Yacc program. But in the definition section, we have included stdio.h. As it is a Lex program, we are invoking the Lex also here only. So for that. Okay. And we have taken a variable C so as to keep the comment count so that we can print the number of comments. Okay. And this is the rule section. In the rule section, what we are trying to write, slash star, right, for a multi-line comment, and a pattern star and slash. In between, what I can have anything, a number, character, space, new line, whatever it is, except star and slash. So that's what we are trying to write, except star and slash. This caret symbol indicates except. When it is written within this opening and closing bracket, it indicates except. If it is written outside, it is indicate begins with, right? So we need to refresh our wildcards and the regular expressions of Unix shell. Okay, except star and slash. You can have anything appearing 0 or more. You should begin with the pattern slash and star, and apart from star and slash appearing 0 or more number of times, anything is just ignore until you get star and slash. When you get the star and slash, we increment the comment count. Fine. This is for multi-line. Similarly, you can have anything. You have a double slash pattern. After that, you can have dot star. You may ask me that why you didn't use dot star earlier. The dot star is not used because anything apart from star and slash should be allowed. So here, one character that may be, or 0 or more characters that may be anything except slash n. Except slash n. Once you get the slash n, you are incrementing the comment. This is contradicting to this. Here we have written this part inside and pattern again slash n outside. But instead of this, we have written apart from slash n, means once you get a slash n, you increment the comment. And the third rule is telling if you get anything else, that means which is not following these two patterns, means which is not part of your single line comment, not part of your multi-line comments, means it is part of your program. That is A to Z or 0 to 9 characters or numbers. Then we are printing the text what we have recognized into a file which is pointed by YYOut. YYIn and YYOut are the predefined file stream pointers for connecting the input file or the output file, right? So we are using YYOut as a output file, and we are recognized text will be there in the string called YY text. That will be written onto the file called as a YY file pointed by the file stream pointer YY out. The main program we are using argc and argv, argument count and argument vector, because we should take the input from one file, we should write the output into the other file. Means this is non-interactive program. It doesn't ask you to enter input to something, right? No, it is going to take input from one file, write the output onto the other file, right? That's the reason we are opening argv of first argument, whatever you are passing with a dot out in a read mode, means that is your input file that is connected to your YY in, and the argument 2, the second file, whatever you pass with your a dot out, will be a output file that will be connected to your YY out. Then you are invoking your YY lex, recognize the comments, eliminate the comments, and then write the rest of the thing onto your file. And also after that, it is going to print the number of comment lines is this one, fine. Okay. Once again, we shall execute this program, but let me see the program. Yeah, I have a file called. Okay, this is the file we have. I have one single line comment, one multi-line comment, and one declaration. So this is going to be coming in the other file, right? Okay, we shall execute this. Here, lex lab 6a.l. Okay, gcc lex.yy.c hyphen link library. Okay, dot slash a dot out. So like other programs, I cannot press enter immediately after writing dot slash a dot out. I should specify the input file and the output file. The input file which we just opened is ip.c. I shall specify that ip.c, and I haven't created the output file. We can give anything. The reason is that file is open in write mode. If the file is not existing, the file will be created. op.c means our input file is ip.c, our output file is op.c. Right? Number of comments are 2. Is it correct? Yes. Let's see. There is one single line comment and one multi-line comment. Fine. We shall open the output file. Is it created? Yes. op.c is created. Open. This is not having the comment lines. Comment lines are eliminated. We are just remaining with the C program, that is our entity. Right? This is our program 6a, which is just a flexible. Now let's move on to the 6th B, which is a combination of Lex and Yacc program. Yeah, this is also a simple program. What the program should do is it should recognize identifiers, operators, keywords in a given C program file. Right? Should just recognize. Fine. That's what is the thing. Let's see what we have did. We have stdio.h, and y.tab.h. The y.tab.h, as I told, to establish the connection between the Lex program and the Yacc program. This is the Lex part of the program, 6b.tab6b.l. And as usual, YYL well, so that to convert the string that is read to the lexical value, that is integer or floating point value. So that's what is the thing. Here, observe. If you get a /t, take no action. There's nothing to be done. But the next rule tells that if you get plus or minus or slash or star or equal to or greater than, less than, all these things, you can also add double and or all those things. We are printing that it is an operator. And what is that operator? Just like we did echo, here we are printing that string, whatever is read. And we are returning a token by the name OP. And as usual, the tokens will be defined in your Yacc program, right? The name of the token is OP. And if you get digits, that is one or more digits, we are converting the YY text, the tokens string will be stored in YY text, which is converted into integer and is placed into YYL. That means it will be placed into the external val, so that we can return the value as it is to the Yacc. That is your Yacc program. And we are printing the digit and its value, which is present in YYL val, and we are returning the token. The name of the token is digit. So first token we returned is OP operator. The second token we returned is digit. Next, if we get int, char, bool, float, void, etc., all these things, for you can add all 32 keywords, right, of C programming language. If that is the case, we're going to print there the keyword and what is the and observe here we are not here we converted into integer, so we are using %d and we are printing YYL. But here we are just printing the string as it is. Here also you can see we are just printing the string as it is. Means to say whenever we recognize a token, by default it will be a string. So you can convert it into whatever the value, to float or integer or whatever it is. So for that reason, here only we did conversion using ATOI function, but in this case we are just printing the text as it is. Here also for keywords we are printing the text as it is. So that's why we are using the format specifier %. Yes, and we are just printing YY text and return the token by the name key. So first token is operator, second token is a digit, third token is a key. Apart from that, if you get A to Z or capital letter A to Z or 0 to 9 appearing one or more number of times, that is also printed as identifier with YY text as it is, and we are returning that it is a ID. So totally 4 tokens we are returning: operators, digits, key, and ID. Apart from this, if you get anything, take no action. That's what we have did it in our Lex program, right? Of the 6B Lex. The Yacc should recognize this. It's a very simple thing what we can see. Yeah. stdio.h, lib.h is included. ID, digit, key, OP. This is not tokens. This is to keep track of the count, number of identifiers, operators, digits, keywords. So as to keep the record. And next, after the definition section, here we are defining the tokens. Yes, we told 4 tokens: digit, ID, key, operator, right? And this is our grammar written in the proof section and the concerned action. See, what is that input is nothing but the argument is start state produces digit input, digit input. When digit you get, you are going to increment the digit. Yes, this input is now a non-terminal, which continues. After digit you can have an ID, or after the ID you can have a operator or something like that, or keyword, whatever it is. Fine. So digit input or ID input, then ID will be incremented. Key input, then keyword will be incremented. OP input, operator will be incremented. Means or else it can have only digit or only ID or key or operator. Means something like I produces digit I or ID I or key I or OPI or digit or ID or key or OP, right? And this, when we recognize this grammar or when we recognize a string which matches this grammar, then the concerned ones are incremented. And here we are calling extern int YYLex, and we are calling YYParse. Means and then we are taking a file stream pointer, defining file stream pointer. Actually this is not needed in fact, but let it go. And we are opening a file. Name of the file is 6b.c in a read mode. Means this file should be existing, and that is connected to uh, my file, right? If my file is not able to be opened, we're going to tell that the file opening error. This and all is just a validation. Okay, and we are connecting my file to YY. So many things we are trying to do. Instead of that, we can connect it, open the file, and directly have connected it to YY, and that could also be done. Means in this place, without file stream pointer definition, you would have connected it to YY. That can also be done. Fine. And this parser should run continuously for the entire program. For that reason, we are including that in a do while loop until the end of the file connected to YY in file stream pointer. Keep on invoking YY parser, right? And after that, you just print all the things, whatever you have recognized, identifiers, keywords, numbers, and operators. And if at all error appears, we are invoking or we are writing the function for YY error, YY parse automatically invokes the error YY error whenever the error appears. We shall compile and see this program. Right. Let's lab 6b.l lab 6b, sorry, that is yeah, d lab 6b.y, then gcc lex.yy.c, then y.lab.c hyphen ll. Okay. Okay. And now we should once again open, I think 6. We should have a file called 6b.c. Yeah, we have a file called 6b.c. I'll let you open that. Some program is there, C program, no issues. Okay. /a.out. So it has recognized the set of operators, keywords, and all those things together. But the thing is that it has recognized even this in the including hash include opening left parenthesis and right parenthesis also included, because the reason is in the program we have taken greater than and less than also as a operators. That's the reason it has recognized. That's precisely working according to the specification. That's what it is. It has taken stdio also as an identifier, because this has supposed to be processed by your preprocessor, right? So, but it is recognized this one as this, and h is also considered as an operator. And then you can see that int main is taken as an identifier because it doesn't belong to your keyword, right? Like that. Okay, and this is the working of this this program. So it is telling, and after each line it is telling how many digits and how many all these things are recognized. Right? That's the end of the program 6b. Right? So fine. At this point, I need to mention you that this programs 1a, 1b means there is program 1 containing 1a, b, and program 2 containing only 2, which is a Lex and Yacc program. 3 is for your LL1 parser, 4 is your introduce parser, 5 is your pre-address code to machine code generation, and 6 is one Lex program and one Lex and Yacc program. Right? This much are the programs of SS and CD. Why SS and CD? Because the Lex and Yacc tools are the system software tool. So Lex and Yacc programs are of SS, and program 345, that is top-down parser, bottom-up parser, as well as machine code generation. These are your CD programs. So we have successfully completed Lex, Yacc, and compiler design program. This much will be there for your internals. This much will be there for your internals. And OS programs, anyway, it will be explained by the sir, and videos will be posted. But that you are supposed to write it in your record. Okay. These programs along with those programs, totally 9 programs, 1 to 9. All of them must be written in the record, because the record component will also have the marks in your evaluation apart from the